Welcome to this wrap-up session about Nicholas Copernicus's On the Revolutions of the Heavenly Spheres. Depending on which section you're in, you may need to skip to a later part of the video. If you look just below the video, I will tell you at what minute to skip to. If you're in my second section, which is from 12:30, then this entire video is appropriate for you. So in our last class, we got to this point where we had just seen Copernicus's reasoning for why the Earth is round. Main point about that was that although Copernicus does talk about and give arguments for the Earth being a sphere, that is not because it was a new idea. In fact, it's a very, very old idea. And the evidence that he provides for why the Earth is a sphere is just pretty much straightforward scientific geometrical reasoning based upon everyday experiences, like viewing ships at sea and so forth. So nothing too surprising there, except perhaps you hadn't thought about how easy it actually is for you to tell that the Earth is in fact a sphere. Now when he moves on to chapter 4, you'll notice the reasoning will sound quite a bit different. And you'll recall in the first section, the reasoning that he gave for why the universe is a sphere was not like what we found in this argument about why the Earth is a sphere, right? Why the Earth is a sphere, we found just what you and I would accept as very good, valid arguments. Whereas here we saw that his arguing was based upon analogy, upon aesthetics, upon a certain sense, a certain intuition about what nature should be like. As we said in one of the sections, in every period, there's a sense of what it is natural for nature to be. And for Copernicus, the idea of this, what is natural, is greatly dominated, as it was for the ancients, with notions of spherical or sphericalness, roundness, circularity, and so on. So when he turns to this section on how that the motion of the heavenly bodies is uniform, eternal, and circular, something very similar is going on. So he talks about how I shall now recall to the mind that the motion of the heavenly bodies is circular, since the motion appropriate to a sphere is rotation in a circle. So there's something about circles that makes the rotation of a sphere ought to be in a circle. It's appropriate for a sphere to rotate in a circle. Not just any path that returns to itself, but a perfectly uniform path. It says, by this very act, the sphere expresses its form in the simplest body, wherein neither beginning nor end can be found. So there's this odd idea here that the sphere expresses its form by moving in a circle in its act. So an analogy here would be, a rude person, it's like the body, expresses him or herself by being rude to other people, right? So it's appropriate to be angry, to butt into line, to do all these kinds of things. That's the appropriate way in which rude people express themselves. Similarly, moving in circles is the appropriate way in which spheres should express themselves. Again, we're returning to a kind of analogical, aesthetic kind of reason here. So he talks about the various motions that are found, the various circular motions, right? He says here, in the first place, so although these are all circles, there are various different irregularities in those circles, right? In the first place, they, meaning the planets, do not swing around the same poles as the first motion, but run obliquely through the zodiac. The zodiac, of course, is that circle of, let me find actually an example of the zodiac to show you. Here we go. So remember, the zodiac is this set of constellations that is essentially oriented around what's called the ecliptic. So the ecliptic is that circle in which the sun and the planets move, right, relative to us. So here's the Earth. And let me skip to another spot so you can really see that. So here's the Earth in reality, right? This is in the Copernican system. And there's the zodiac, are the constellations in this circle. And when we look at the sun from the Earth, we see the sun against the background of a certain constellation of stars. And that's said to be the zodiac of that part of the year, right? So when it's Pisces, which is in February, part of it's in February, then the Earth will be where it is situated around the sun in February. And over here, on the opposite side, will be Pisces. Of course, these constellations are here. They're way out here, right? But they're seen as more or less in this circular pattern on the sky. Now, what he's saying in this part of the text is that let me find it again. Here we go. What he's saying in this part of the text here is that although they move in circles, the planets move in circles, they don't actually move in that zodiac in a perfectly lined up way. Instead, they are slightly oblique to the zodiac. So if we go back to that image on the video, you can see sometimes maybe when the Earth is over here, Venus passes towards the top of the zodiac, whereas maybe when the Earth is here, Venus looks to be further down in the zodiac. So it moves obliquely with respect to the zodiac. That's because the plane of the stars is not perfectly aligned, right? In fact, not the plane of the planets. The plane in which the planets essentially move is not perfectly aligned with the zodiac. It's slightly tilted. Okay, so back to the text. So that's one thing, right? Secondly, these bodies are not seen moving uniformly in their orbits. He's referring to the retrograde motions, right? Moreover, we see the other 5 planets also retrograde at times. The stationary at either end of the regression. So, of course, when a planet goes forward, it has to be momentarily stationary before it starts going backwards. At least this is how it looks in the sky. He goes on to explain this is why the planets are called the wanderers, because they move around in irregular and strange ways relative to the stars. But all of that is his kind of background. He says, nevertheless, we must acknowledge nevertheless that their motions are circular or compounded of several circles, because these non-uniformities recur regularly according to a constant law. This could not happen unless the motions were circular, since only the circular can bring back the past. So the argument here is, again, a basic intuition he has, on which all the ancients and medieval writers had, which is that the circle and circular motion is the only motion that perfectly repeats itself. Now, circular motion is regular and it repeats itself. And the planets their motion is irregular, but they also repeat themselves. Now, if their motion is irregular, but they repeat, and circular motion is really the only motion that repeats, then there must be some way to reduce the motion of the planets to motions within various circles. Of course, this is no different than what Ptolemy was thinking so far, right? His method was the motions of the planets seem irregular, retrograde, non-uniformities, and so on, and nevertheless, they must be reduced to, if not 1 circle, then 2 circles, or 3 circles, or 4 circles, but ultimately to circles, because only circles repeat. So there's this idea that time and repetition in time requires at some fundamental level, or at the fundamental level, that the motions are reducible to patterns of circles. So Copernicus shares the same exact idea. He says, thus, for example, by a compound motion of circles, the sun restores us to the inequality of days and nights, as well as in the 4 seasons of the year. Several motions are discerned herein, because a simple heavenly body cannot be moved by a single sphere non-uniformly. So it can't just be a single circular motion. because a single circular motion cannot move something uniformly. So he's sticking to that Aristotelian principle. So why? He gives us some reason here. So that is an Aristotelian principle, but why would you think that something moving in a perfect circle around its center should not move irregularly around that circle? Well, he says, for this non-uniformity would have to be caused either by an inconstancy, whether imposed from without or generated from in the moving source, or by an alteration in the revolving body. So, in other words, if a body were to, say the Earth moving in a circle, were to speed up and slow down on that circle, it could only do so if it were something caused it from outside to slow down and speed up, or it sped itself up and slowed itself down. And he says, from either alternative, however, the intellect shrinks. So this you and I wouldn't think of as a very scientific reason, but it might be. Still, in modern science, there are things that if you propose them, even without testing, your professors or other people their intellect will shrink from it. What does that mean, essentially? It means the very thought of it conflicts with your sense of the way nature ought to work, right? When people talk about ESP and or even things in quantum mechanics, though they are true, certain of them seem to strike us as absurd, right? And we have to get used to them. But our initial healthy instinct is that nature, when we look at things in nature, they should be like other things we see in nature. And we build up in that way a kind of sense of what nature should be like. And he's saying here that something spontaneously speeding up and slowing down is just not the way nature works. It's too ugly. God would not work in that way. He even makes it a kind of moral case here. He says it is improper to conceive any such defect. So he sees such slowing up and slowing down and speeding up of a planet as a kind of defect, right? Like a moral defect in objects constituted in the best order. So he's almost saying here, it's unworthy of God to make it such that planets moving in circles speed up and slow down. So don't think it, right? If that's the case, then instead we have to propose that they are moving uniformly in circles, and their non-uniformity is either due to their moving on multiple circles, as in Ptolemy's system, or as in the Copernican system, because we too are moving on one of those circles. And because we are moving in a circle, it makes the other planets and their motions look like they're not moving regularly on circles. So the irregularity here is due to our own perspective. And that's what he proposes here. So this is where he takes a real departure from Ptolemy, right? He says, hence I deemed it above all necessary that we should carefully scrutinize the relation of the earth to the heavens, lest, in our desire to examine the loftiest objects, we remain ignorant of the things nearest to us. What is nearest to us, he's talking about? The motion of the earth. And by the same error attribute to the celestial bodies what belongs to the earth. So this is his key idea. Undoubtedly, although he doesn't mention it here, one of the intuitions that people have always had, and you can kind of have this intuition as well, about circularity and repetition and their connection, is planets and the motion of the planets and the sun are always related to time. And time is essentially understood by us to be a series of circles. If you look at a watch, and you might ask yourself, well, how could something keep regular time, right? Continually repeat the same things. Mechanically, your suggestion would probably be that that would be possible to model using circles, right? An example would be a watch. When you open up a watch, it keeps regular time, right? And you're not surprised that when you open up the watch, it's full of gears that are circles that move regularly. Even watches, you can get watches that have that tell the day of the month and which month it is in the year. And that's not completely regular. That's a bit like the retrograde motions, right? Some months have more days, some months have less days. But in any case, you can, that can still be modeled within a watch, usually in this case an expensive, complicated watch, using nothing but gears and further circles. So that can be done, and it is done, and with the same kind of fundamental idea behind it. And it seems to be true that keeping time in this way is in some way related to circles. Now, of course, Copernicus thinks of these circles as somehow like it's part of the fundamental structure of the universe that they have to be circles. So chapter 5, does circular motion suit the Earth? So now he's moved on to his main idea, right? This is where he's starting to justify this main idea that maybe the Earth moves. And you should pay attention because you'll notice here there's no data, there's no empirical evidence he's going to present. In fact, he's not even going to be able to present any very strong arguments that the Earth moves. He doesn't have any. He has most of his arguments appeal to the kinds of intuitions about how nature operates that were typical of Aristotelian philosophy. He actually is kind of using Aristotelian reasoning to argue that it's suitable for the Earth to move. Now, actually, there's two kinds of arguments that he uses. One set of arguments are arguments that don't try to justify anything. They simply want to make it to kind of get past the objections and make it comprehensible that the Earth could move, because there are lots of objections, right? The Aristotelians have plenty of objections. It doesn't seem like we're moving. We can't detect that we're moving empirically. We don't feel like we're being flung off the Earth or anything like this. And so it takes some leap of the imagination, right? It's not obvious whatsoever. In fact, it's a crazy idea, as he said earlier, and it still is. So it takes a kind of faith in certain kinds of mathematical geometrical arguments to even imagine that it could be possible that the Earth is moving. So that's one set of arguments. Then there's another set of arguments that really do try to justify and prove in some way that the Earth should be moving. But as we'll see, those appeal to Aristotelian philosophy. And today would no longer be deemed scientific reasons. So we'll see what those are. So the first argument we see here, this is one of the first class of arguments, right? He says, every observed change of place is caused by motion of either the observed object or the observer, or, of course, by an unequal displacement of each. So he's saying observed change of place isn't only caused by the changing of place of the thing that you observe. It can also be caused by the observed object moving, or by the observer moving, or by they're both moving but unequally, right? So when things move with equal speed in the same direction, the motion is not perceived. I mean, relatively to the thing seen and the spectator. So two cars traveling on the highway, traveling at the same speed. You look at nothing but the driver in the car next to you, and they look like they're sitting there in space right next to you, not moving. You are not moving, they are not moving. It's because you're both going the same speed in the same direction. It is the Earth, however, from which the celestial ballet is beheld in its repeated performances before our eyes. So we see everything going on in the celestial ballet in the skies from our standpoint on the Earth. Therefore, if any motion is ascribed to the Earth, in all things outside the same motion will appear. So if the Earth is moving, we will see that motion in the object that we look at, but in the opposite direction, as though they were moving past it. So again, think of the example in the car. You're sitting in a car and someone is next to you in the next car, and you're going the same speed, and then you start to speed up. You don't see yourself speed up. You see them start to go backwards, right? From your point of view. So a key idea for him is that when we're looking for the Earth's motion, we don't just look for it in the planets. We need to look at it, whatever the Earth's motion in one direction is, that will be seen in the opposite motion of the planets, right? This doesn't establish anything. It's just starting to open the idea of motion being relative to the vantage point, just explaining that possibility, right? Moreover, since the heavens, which enclose and provide the setting for everything, constitute the space common to all things, it is not at first blush clear why motion should not be attached rather to the enclosed than to the enclosing, to the thing located in space rather than to the framework of space. So here, this is a positive argument, right? This belongs to the second class of arguments. But he says the heavens are kind of the framework for the universe. So it's not at first blush clear, right? He's saying, but why? He's not saying we can't ascribe motion to the heavens and rest to the earth, but he's saying, but why should we, right? Wouldn't it make more sense if we were moving and not the whole universe was moving? Seems strange that the whole universe moves and yet we stand still, right? Maybe it doesn't even make sense. It's like it would be kind of like you driving in a car through a city, and instead of saying that you're moving, saying the city is moving. So shouldn't the city kind of by definition be at rest and you be the one to which motion is ascribed? Why shouldn't it be that way? Okay, a little further on. It will occasion no surprise, and if addition to the daily rotation, some other motion is assigned to the Earth. That the Earth rotates, that it also travels with several motions, and that it is one of the heavenly bodies, are said to have been the opinions of Philolaus and the Pythagorean. So he's saying this idea that it moves shouldn't surprise us, but perhaps it also moves in more than just one way. Maybe it's not just the daily rotation. That's the rotation that, from Copernicus's point of view, is responsible for making it look like the stars are rotating, right? That's the rotation on the axis. Maybe there's some other motions assigned to the Earth. And he says, well, this was the view of a Pythagorean, right? Philolaus. Okay. Notice, what was that chapter called? Does circular motion suit the Earth? What is its position? That's the strength and the extent of his arguments in this chapter, under that heading. Chapter 6, the immensity of the heavens compared to the size of the Earth. So this is a complicated section, and if you want to, given what I talked about in the zodiac, if you look up a zodiac, an actual picture of the zodiac, you can kind of pick through these arguments, and I have done that. The goat is a certain zodiac sign, the crab. They're actually on opposite sides. So if one is behind you, one is in front of you, all the time, because they're on opposite sides from each other. The basic argument here in this section is that when you stand on the surface of the Earth, which is a sphere, and you look out into the distance, in all directions, you have what you call your horizon. It's the circle that you can see, right? In all directions. And you're always at the center of your horizon, right? You're always at the center of this circle that you can see, and then the Earth curves too much and you lose sight, right, of everything else. And you're not at the center of the Earth. You're never at the center of the Earth. You're always somewhere. If there's the Earth, right? Let me get it right here. The Earth. Your horizon is some little circle on the surface of the Earth, right? Somewhere. And as you move, that circle is in different spots, of course, but it's always tangent to the Earth. Now, he goes through a geometrical argument here to try to show that if I'm here on the Earth, right, tangent to the Earth, this is my horizon, and I can see all of this sky, right? I can't see the sky down here, for instance, because if I'm here, the Earth is blocking the sky down here. So I see part of the sky above me, right? And it should not be a perfect hemisphere that I see, right? I would only see if the universe is a sphere and the Earth is directly in the center of, or we're in the center of it, or no matter where it is, but in any case, the Earth is somewhere near the center of it, and I'm on the surface of the Earth, I shouldn't see the entire an entire hemisphere, because I'm not in the center entirely. I'm somewhere outside of the center. So what's above me should be less than a full hemisphere. And what's below the Earth, the horizon, right, should be more than a whole hemisphere. But when you do that, it seems like that is just not the case. No matter where you are on the Earth, at what time of year, you can kind of do a geometrical proof that you are actually, that your horizon cuts the sphere of the universe perfectly in half, as if you were right at the center of the universe, no matter where you are on the Earth and what time of year it may be. So what does that mean? Well, it's kind of like a proof that if I were to, which you could do, right? If you were to look at the stars in the northern hemisphere near the North Pole, and to look at the stars at the South Pole, they should look different if they were very close to us because of the difference in perspective. And what if you were to do a geometrical proof like this, and it turned out that every time you tried to find your location relative to the stars, you get the same location no matter where you are on the planet? You might think about that for a minute, but the answer is the only way that can happen, unless you've made a mistake, is if the distance from you to the stars compared to the distance between your different locations on the Earth is so immense that the difference in your position on the Earth makes no difference to the calculations whatsoever. This is Copernicus's idea. If it looks like I'm always bisecting the universe, or that my horizon always bisects the universe no matter where I stand, then the different spots I choose on the Earth, the distance between them must be vanishingly small compared to the size of the universe itself, the distance away from us that the stars are. So he says this kind of at the bottom here. A horizon then, in this way, always bisects the ecliptic, which is a great circle of the sphere. But on a sphere, if a circle bisects any great circle, the bisecting circle is itself a great circle, meaning the circle of our horizon is itself a great circle. A great circle is a circle that bisects the sphere that it's on. So bisects the sphere of the universe. Consequently, a horizon is one of the great circles, and its center is clearly identical with the center of the ecliptic. So no matter where you are, it looks like you're at the center of the ecliptic, the center of the universe. So he says, yet a line drawn from the Earth's surface must be distinct from a line drawn from the Earth's center, right? Nevertheless, because these lines are immense in relation to the Earth, the lines drawn from the Earth's surface to the firmament, to the stars, or from the Earth's center to the same point. Nevertheless, because these lines are immense in relation to the Earth, they become like parallel lines. Because their terminus is enormously remote, they appear to be a single line. For in comparison with their length, the space enclosed by them is imperceptible, as is demonstrated in optics. This reasoning certainly makes it quite clear that the heavens are immense by comparison with the Earth, and present the aspect of an infinite magnitude, while on the testimony of the senses, the Earth is related to the heavens as a point to a body. So the size of the Earth relative to the universe is kind of like the size of a point in relationship to the size of a body. But a point is one-dimensional. It has no size relative to a body. That's what he means by infinitely vanishing compared to it. And an infinite to an infinite, finite to an infinite magnitude. So this is a major conclusion. Notice how he gets there. He doesn't have an intuition or an idea or even a scientific foundation for saying the universe is so much larger than anyone in the church or anyone else had ever imagined, right? What he does is he has this feeling about how to make sense of the system of the solar system, the universe. He has problems with the Ptolemaic system. He tries to solve them, right, using his circles. And he finds to do so, he has to ascribe motion to the earth. And now, he uses only this argument in terms of the size of the earth itself, but he also needs the same idea, and this is why he pursues it here. If we're moving around the sun, and we're as we are in the Copernican system, then we're not only not directly in the center of the universe, we're by our standards, very far away from the center. Because for Copernicus, the sun is still the center. So that would be his center, and we'd be very far from that. So the kinds of different things we should be seeing, because we are not at the center of the universe with respect to the stars, should be really great, right? And if we don't see them, then that can only be because the stars are so incredibly far away. He's already opening that idea here, but he's only doing it as part of that first set of arguments, namely those arguments that try to make it conceivable or to answer objections that would arise from the notion that the earth moves. So if you propose the earth moves, then a clear objection would be that we should see its motion clearly in the stars, but we don't. Answer: the stars are so far from us, so immensely far from us, that change in their motion and in their perspective relative to the earth and due to the earth's motion is completely undetectable. So in the process of a regular, attempt to justify his views, he stumbles into, as it were, a fundamentally radical new view of the universe. To think that suddenly that tidy little universe, which was quite small, the Aristotelian and medieval Christian universe, is suddenly the earth is like a speck of dust, infinitely tiny. That's raises some questions, right? Puts questions to the traditional views. Chapter 7, why the ancients thought that the earth remained at rest in the middle of the universe. Well, again, this is, the ancients, of course, he's referring to the Aristotelians and others, why was it at rest? And he's going to give us now the Aristotelian arguments. He says, accordingly, the ancient philosophers sought to establish that the earth remains at rest in the middle of the universe by certain other arguments. As their main reason, however, they adduced heaviness and lightness. Earth is in fact the heaviest element, and everything that has weight is borne towards it in an effort to reach its innermost center. The earth being spherical, by their own nature, heavy objects are carried to it from all directions at right angles to the surface. Hence, if they are not checked by its surface, they would collide at its center, since a straight line perpendicular to the horizon at its point of tangency, where a sphere leads to the sphere's center. But things brought to the middle, it seems to follow, come to rest at the middle. So essentially, Earth tries to move towards the center of the universe. That's why the earth is at the center of the universe. And that's why it is at rest, right? This is the Aristotelian argument. All the more then will the entire earth be at rest in the middle, right? In like manner, the ancient philosophers analyzed motion and its nature in a further attempt to confirm their conclusion. Thus, according to Aristotle, the motion of a simple body is simple. And of the simple motions, one is straight and the other is circular. Of the straight motions, one is upward and the other is downward. Remember, of earth going downward and fire going upward, and these are the straight motions. And then there are the circular motions, right? Hence, every simple motion is either toward the middle, that is downward, or away from the middle, that is upward, or around the middle, that is circular. So he's saying the ancient philosophers, Aristotle, categorized motions in terms of being up, down, or circular. And this is the fundamental framework they used, right? to be carried downward, that is to seek the middle, is a property only of earth and water, which are considered heavy. On the other hand, air and fire, which are endowed with lightness, move upward and away from the middle. To these four elements it seemed reasonable to assign a rectilinear or straight motion, but to the heavenly bodies, circular motion around the middle. That is what Aristotle says. Right? Therefore, Ptolemy said, if the earth were to move merely in a daily rotation, the opposite of what was said above would have to occur, since a motion would have to be exceedingly violent and its speed unsurpassable to carry the entire circumference of the earth around in 24 hours. So he's saying Ptolemy actually used this reasoning to disprove or to reject the daily rotation of the earth, because he said the earth moves in a straight upward or downward, things on the earth. So in other words, circular motion is violent compared to things on the earth. And so since it's violent, circular motion is not natural to the earth, and it would have to go at a very great speed around on its axis to create the what we see in the sky, the rotation in a day. He says this would basically destroy the earth. It would fly into pieces. Things would undergo such an abrupt rotation that is utterly unsuitable to these bodies, and seems more likely, if they had been produced by combination, to fly apart unless they are held together by some bond. The earth would long ago have burst asunder, he says, and dropped out of the skies. And what is more, living creatures and any other loose weights would by no means remain unshaken, nor would objects falling in a straight line descend perpendicular to their appointed place, which would meantime have been withdrawn by so rapid a movement. So if the earth is spinning as quickly as we actually know it is, because things like earth and things like water and fire only undergo straight motions. If the earth were being rotated quickly in a circle, then when you dropped the ball, it would fall not directly down, but it would fall somewhere behind, right? So the earth is rotating quickly, you drop a ball, it shouldn't fall, and it only goes like this, right? So it's going to hit the earth not where you above where you dropped it, but somewhere later because of the spinning. Why? Because we know now, of course, if you drop a ball on the earth, it actually is spinning with the earth. But he's saying, based on the Aristotelian idea, that doesn't make any sense, right? Because if the earth is spinning, it must be spinning because something is spinning it, because it's not natural for the earth to spin on its own, because it's made of matter. It's made of earth, which doesn't naturally spin. So another piece of earth that's not being rotated would have no reason to go around with the earth itself, and so would fall behind. Same thing for he mentions clouds. Clouds should fly behind. They should not be able to keep up with the earth. Birds and so on. This was typical examples that they gave, right? If the earth rotates at such speeds, how can the birds possibly keep up with it? Now chapter 8, so he's given the Ptolemaic arguments against the motion of the earth and the Aristotelian arguments against the motion of the earth. Now he's going to not prove that the earth moves again, but now we're going to get these arguments, why the other arguments don't prove anything, right? Yet if anyone believes that the earth rotates, surely he will hold that its motion is natural, not violent. But what is in accordance with nature produces effects contrary to those resulting from violence, since things to which force or violence is applied must disintegrate and cannot long endure. On the other hand, that which is brought into existence by nature is well ordered and preserved in its best state. So all he's saying here is, I disagree with you, Aristotle and Ptolemy. I accept that there are certain motions that are natural and others that are not. But if I say that the earth moves in a circle, then I am also saying that circular rotation is natural to the earth, not violent. And so when you say it should fly apart, I say no, that motion your categorization of motion is simply wrong. Circular motion doesn't only belong to the fifth element, whereas straight motions up and down belong to the other elements. No, circular motion belongs to all elements, and so it is natural. And he even uses this as an argument. saying, well, now I can explain if circular motion is natural to things other than the heavens, to the earth, then things on the earth could, like the birds, are undergoing both circular motion and straight motion at the same time. And they can do so without that making them fly to pieces or anything, because it's natural. And what is natural, as we see here, endures and is well ordered and preserved in its best state. So Ptolemy has no cause then, no reason, to fear that the earth and everything earthly will be disrupted by a rotation created through nature's handiwork, which is quite different from what human art or intelligence can accomplish. But why does he not feel the apprehension even more for the universe, whose motion must be swifter, bigger, and bigger the bigger the heavens are than the earth? Or have the heavens become so immense because of the indescribable violence of their motion, driving them away from the center? Well, they also fall apart if they came to a halt. Were this reasoning sound, surely the size of the heavens would likewise grow to infinity. Now here, Copernicus is not being particularly fair to the Aristotelians, right? Just as above, he's kind of just rejecting not the idea of natural motion, that certain kinds of motion are natural, but he's certainly not arguing within their framework in a quite fair way. Why? Because he says, well, you say that by circular motion that would cause the earth to explode and to fly to pieces, but of course the earth, in order to have explain the daily motions of the stars around the earth, you need a certain speed for the earth to rotate on its axis, right? Which is one rotation in a day. That is incredibly small compared to how fast the heavens would have to be moving to get around the earth in one day, right? Just if you have a circle, if you have a wheel, right? If this, in the time that as this goes around, right? You can see I'm going around the 25 here. If I'm at this distance from the center, if I take the same amount of time to go around here and to go around here, right? Here, I don't have to go nearly as fast to get around in the same time here, because I've traversed such a longer distance to go once around here than here. So if the Earth has to go at a fairly quick speed to get around in one day, just rotating, then the stars, which are immensely far away, as we've already learned, would have to go in an unimaginable speed to get around us in one day. So why don't they fly apart too? Well, the Aristotelians would say, obviously, that's because they are made of that fifth element, for which circular motion is natural and is easy, right? It's the easiest kind of motion. It's the most natural and enduring motion for them. So it's natural to them, so they would not fly apart. So the Aristotelians actually have a perfectly, even according to Copernicus, the way he's been arguing, a perfectly good response to what he's saying here. He's just kind of saying, I don't accept your point of view at all. Here he gives another example of this kind of when a ship is floating along, the sailors see its motion mirrored in everything outside, right? This is for his period, the example I gave of the two cars. Instead, he's giving the example of a ship moving, right? In the same way, the motion of the earth can unquestionably produce the impression that the entire universe is rotating. Of course, rotating in the opposite direction than the earth is moving. The reason may be either that so he has another example of this. We would not only say that not merely the earth and the watery element joined with it have this motion, but also no small part of the air and water is linked. Also, no small part, meaning a large part or all of it, of the air and whatever is linked in the same way to the earth. The reason may be either that the nearby earth, mingling with the earthly or watery matter, conforms to the same nature as the earth, or that the earth's motion acquired from the earth's by proximity, shares without resistance in its unceasing rotation. So here's the answer to those questions about birds and other things. Why don't they get left behind? Because due to their proximity, they share in the nature of the Earth or in the Earth's motion, right? Either they're dragged along with the Earth because they're close to it, or because it's natural for them to remain around the Earth. Not a great argument, right? Okay. Here's an interesting argument. I won't go through this one, but this is, you can read through this yourself. Here he says, maybe we should ascribe motion to the Earth instead of to the universe, because immobility is deemed nobler and more divine than change and instability. Right? This has always been part of the Aristotelian view. Again, he's taking part of the Aristotelian view, which is that motion, but of course motion in a straight line, is less divine and is unstable. And immobility, they never said immobility is nobler. They said motion in a circle is nobler and more divine. And ultimately, immobility is even more divine than circular motion, right? Because only God is unmoved, right? But maybe we should then say the Earth moves in its orbits and so on, circularly, and that the universe does not, because the universe is divine, and the Earth should be changeable and unstable, right? And less noble and less divine. So maybe this is a good reason to ascribe motion to it. Again, he's using the Aristotelian and Christian kinds of points of view, but in a way that they weren't used before. Here, chapter 9, this is quite an interesting, it's not interesting for the main content, but some of the things he says along the way, which you should think about. What is so important about Copernicus is that he loosens up the view of the universe that had been there for so long, and he opens for the possibility of a radical reinterpretation of our place in the universe. And of course, the place that you believe that you have in the universe is very central to what you think life is all about, what you think is important, what you think you should do with your life. And so he created by creating and offering this new model, he created a certain moment of instability, a moment for others to come in and reinterpret the universe according to these new ideas. And one of the key ideas, one of the key changes, right? So we've seen that Copernicus kind of is starting to break down the physics below the moon and above the moon. We already see this because he's describing circular motions to the Earth and to the planets, right? So both above and below. And he's saying that things that are made of Earth can travel both in lines and in circles. He clearly just rejects this division between different kinds of matter, though he accepts the idea of natural motion. In doing so, he's breaking down lots of previous boundaries. But he, in particular, once the Earth becomes a planet, then things very much change, because the planets are just the wandering stars, right? So suddenly the Earth becomes a planet, which is a kind of star. It's not only not in the center anymore, but a way of thinking about it is the Earth is now among the stars. It's now no longer down here where bad things and corrupt things are. It's now up there, right, with the stars, with the divine things. It's no worse than them. It might be similar to them. We'll see Bruno has a lot of ideas and draws a lot of ideas out of this. So here he says, so what he has been saying, we give all these motions to the Earth, it can be regarded as one of the planets, for it is not the center of all the revolutions, right? The stations of the planets, the places where the planets are at different times, the stations, moreover, as well as their retrogradations and resumptions of forward motion, will be recognized as being now movements of the planets, not movements of the planets, but a motion of the Earth, which the planets borrow from their own appearances. Lastly, it will be realized that the sun occupies the middle of the universe. All these facts are disclosed to us by the principle governing the order in which the planets follow one another, and by the harmony of the entire universe. Again, harmony, order, design of the entire universe, if only we look at the matter, as the saying goes, with both eyes. So now he goes through the various spheres within his own Copernican view, right? Nothing here too important. This is a nice summary on page 31 of his system, but it's just the basic facts. The sun is at the center, and so on and so forth. And here's a picture of his system: Sun, right? Mercury, Venus, Earth, Mars, Jupiter, Saturn, and so on. And then notice the immobile sphere of the stars. So he doesn't have a modern cosmological view that you and I have, where there are so the sun is the center of the actual universe, of everything. And the sun is not a star. He doesn't have this idea. And certainly doesn't have the idea that there might be other planets around other stars. That had to wait. Let's see. I think we may be nearing the end. He goes through and talks about the motions and the retrogrades. Again, all these phenomena proceed from the same cause, which is the Earth's motion. Proof of the Earth's triple motion. Now, you can't be fooled by these words proof, because he doesn't prove anything here. He just explains it, right? And he talks about the three motions. The first motion is the rotation in a day. The second is the yearly rotation, which traces the ecliptic around the sun, so that's responsible for the year, right? And the third motion is there's this wobbling of the axis, which creates the seasons. So out of three different, it's not just that for Copernicus the Earth moves, it moves in three different circles simultaneously, right? That's a bit hard to believe, but those three explain three different things. Those three circles, one explains day and night, one explains the length of the year, and the other explains the change of the seasons during the year. Okay, and that is, here are the three motions, right? The Earth, this is the axis, and this is around the sun. Again, circles. Okay, so that's the end of Copernicus. I did want to show, or maybe I will give you a link to, there's a very nice video you should watch if you're interested. Some of you are probably familiar with Vsauce, a nice YouTube channel. If you look up his video, How the Earth Moves, and you go to about 16 minutes and 30 seconds, there's a really brilliant visual explanation, as you can see here, of how the Earth is really moving. This is, of course, beyond Copernicus, but how we are moving in the universe, and probably just watch all the way to the end of it. If you're interested in how quickly we're moving through the universe, at what speeds, and what ultimately the path from a certain standpoint of the Earth might be, then I recommend this video very highly. Okay, that's the end.